Crumple zones. Physics is the study of interactions between bodies of matter. A physicist explains how collisions result in the release of large amounts of energy. They explain that the theory behind crumple zones is supported by mathematical relationships. Consequently, a strong mathematical background is required to complete the calculations for analysing the energy dissipation. In this workshop, the effect of the crumple zone is explored using a physical model. The model has an egg dropped down a tube with a closed end. Popcorn is used to simulate the energy absorbing effect of the crumple zone. The amount of popcorn and the energy of the collision can be varied. The analysis demonstrates how mathematics is applied in designing products that need to absorb impacts. This workshop could be linked to physics, science, or technology design contexts. Equipment comprising everyday building products are required to complete the modelling exercise. The model explored the energy required to break an egg. Lengths of PVC piping with screw caps to close the end are used to contain the collision. A mass is dropped a distance of 1 meter down the tube. At the end of the tube, the egg is protected by a crumple zone comprising of a known number of popcorn pieces. As popcorn is not a regular material, as it varies in size, shape, and density, the students conduct multiple iterations of the same experiment. Different groups model different energy and crumple zone combinations. Changing the mass used varies the impact energy. The crumple zone is varied by changing the amount of popcorn. This produces a range of results for each situation. The impact energy is calculated from the mass and distance of the collision and then graphed against the quantity of popcorn to show the relationship between energy of impact and crumple zone. The model applies the same concepts as an automotive crumple zone and illustrates the purpose of the crumple zone. The use of a real model demonstrates the variability in both modelling and real situations. This allows students to recognise that different answers are viable but carry different risks. From the graph, the students make predictions for a given situation wherein the mass drops 3 meters. Once the students have made a prediction, tests are conducted using the 3-meter tube to see who has the best prediction. The workshop highlights how real-world situations can be modelled using physical models. The same concepts and mathematical calculations can be applied to the model. The calculations use formulae students might relearn in science or in senior school. This workshop also demonstrates that graphs can be used, even when there is uncertainty in the data. The complete workshop would take about 2 hours, but the data collection and analysis could be performed separately. Students could also explore different scenarios, such as different types of crumple zone materials.